volcanoes on the island of Hawaii, nature puts on a dazzling show. Red-hot lava erupts from deep within the earth, exploding high into the sky in fiery displays. And then it rushes downhill in rivers of fire. When it reaches the ocean, the lava cools immediately, sizzling and splattering, exploding, before it hardens into rock, becoming new land. All of the Hawaiian Islands were formed in this way. Of all of Earth's forces, none are quite so spectacular or so important to the regeneration of our planet as volcanoes. Volcanoes are mountains, types of mountains. When they're not erupting, volcanoes look pretty much like any other mountain, as does this volcano, Mount Rainier in Washington State. Or this one, Mount Shasta in California. But volcanoes differ from other types of mountains in two very important ways: how they are created and what they do. To understand more about volcanoes, we have to look deep inside the Earth. The Earth's interior consists of several different layers. The inner core, which is believed to be solid iron and which is very hot. The outer core, which is believed to consist of rocky material so hot and under such great pressure that it is a liquid. The mantle, which is not quite so hot as the outer core and not so liquid. The mantle's outermost portion is solid. This is the solid outer portion of the mantle. Above this is the outermost layer of the Earth, the crust. Together, the crust and the solid outer portion of the mantle form the Earth's outer shell. They are referred to as the lithosphere. It's not always easy to see the Earth's crust. It is covered by vegetation and oceans. But if you could drain the Earth's oceans and strip away our planet's vegetation, the Earth might look something like this. Now we can see the Earth's hard outer shell. And if you look closely, you can also see where the shell is cracked. The red glowing lines mark the places where the Earth's shell is broken into small and large pieces called tectonic plates. Each plate carries a continent, or an ocean basin, or sometimes both. The plates are moving 1 to 2 inches a year in different directions, carrying continents and ocean basins with them. Millions of years ago, the Earth looked something like this. Every continent in a different position. They were so close together, they formed a single supercontinent called Pangaea. Even then, the plates were moving, a few inches a year, and kept moving until they reached their present-day positions. The theory that continents move is called continental drift. When you look at a globe today, you're looking at only a moment in time, because the continents are still moving, inches a year, too slow to see, as they move farther and farther apart. Then, the continents will stop moving apart. They will change directions, coming together once again. Millions of years from now, scientists expect the world to look entirely different. Every continent in a new position, carried there by the moving plates. While we can't see this movement occurring, we can see the effects. Volcanic eruptions are just one of several dramatic effects of plate movement. Here's why the plates are moving. Scientists believe material in the mantle is circulating much as it is doing here. The movement may be caused by heat within the mantle. You can get an idea of how heat can cause a circulating movement by watching rice as it boils. What you see happening within this beaker is similar to what's happening within the Earth's mantle. As mantle material moves, perhaps only inches a year, it causes the plates above it to move as well. In some places, plates are moving in opposite directions. They are moving apart. The area where two plates are moving apart is called a divergent boundary. In some places, plates move past each other. The area where two plates move past each other is called a transform boundary. In other places, plates are colliding. The area where two plates are colliding is called a convergent boundary. The red glowing lines on this globe mark convergent boundaries. These are the places where plates push against each other. Sometimes both plates pushing against each other are carrying continents. In this cross-section, two plates carrying continents are colliding. As they squeeze against each other, the Earth's crust is compressed and folded, rising high into the air. These raised layers of Earth are what we call mountains. Some of the world's highest mountains are a result of two plates pushing against each other along convergent boundaries. But sometimes plates pushing against each other are not both continents. At this convergent boundary, a plate carrying an ocean basin is colliding with a plate carrying a continent. Here's what happens. Because it is heavier, the plate carrying the ocean basin, shown here on the left, dives beneath the plate carrying the continent in a process called subduction. As the plate dives, tremendous heat is created, causing solid rock to liquefy into a material called magma. The magma rises in large globs into the plate carrying the continent. Eventually, the magma stops rising. Some of the globs may form a magma chamber. As more and more magma adds to the chamber, pressures build. Some of the magma finds its way to the surface where it can erupt. The eruption of Mount St. Helens in Washington State in 1980 occurred in much this same way. In a matter of seconds, much of Mount St. Helens was blown away, the mountain literally losing its top. Dense clouds of volcanic ash and debris poured out of a newly formed crater for days on end. Carried by the wind, the ash was blown hundreds of miles, burying towns and cities, turning day into night. The shots you are now looking at were photographed in mid-afternoon. The eruption leaves a ghostly wasteland. Trees toppled like matchsticks. Vehicles tossed about like toys. Crews were brought in to search for the dead and injured. All told, 62 people were killed. Forests and animal life were decimated. And at the mountain summit, a new crater, nearly 2,000 feet across and 500 feet deep. Mount St. Helens is a result of the subduction process, where one plate dives beneath another. The area where one plate dives beneath another is called a subduction zone, and the world's most destructive volcanoes are found in these zones. These symbols mark the locations of active volcanoes. Most of them are located near subduction zones. One region of the world, because of the great number of volcanoes and the circular pattern they form, is referred to as the Ring of Fire. Most of the world's active volcanoes are located in this ring. But some volcanoes occur far from plate boundaries. The Hawaiian Islands are thousands of miles away from the nearest plate boundary, yet this area is among the most volcanically active areas in the world. Scientists believe a hotspot exists in the Earth's mantle below Hawaii. Hotspots are areas where magma has found its way through the Earth's crust, emerging on the ocean floor, where it becomes hardened by the cold ocean water. More magma follows, adding to the formation of an underwater volcanic dome. The dome becomes larger and larger with each eruption and may, after thousands of years, rise above sea level. Every island in the Hawaiian chain, as well as many others around the world, were formed in this way. Hotspots are stationary. The one beneath Hawaii has existed here for over 70 million years. But as we have seen, the Earth's plates are not stationary. As this plate moves, it carries the newly formed island with it. As more magma rises, it starts to build another dome all over. This arrow shows the direction of movement of the plate carrying the Hawaiian Islands. The area glowing in red is the hotspot. The islands farthest away from the hotspot are the oldest. It is the island directly above the hotspot, the so-called Big Island, which is the youngest and most active. Eruptions on the Big Island occur every few years and can last for months, even years. This is what happens during a typical Hawaiian eruption. Magma rises up through the crust into the volcano's magma chamber. The chamber swells. Magma fills channels that lead toward the surface. The magma is held back by rock and sediment blocking the openings. More magma rises. Pressures build. The ground may bulge, causing small localized earthquakes. An eruption can occur at the end of any one or more of several channels or conduits. Seldom do hotspot volcanoes erupt with the explosive force of volcanoes like Mount St. Helens. But what they lack in explosive impact, they make up for in showy displays. Lava fountains are typical of these kinds of volcanoes. Lava can shoot hundreds of feet into the sky for days on end. Lava can also erupt through cracks in the ground, creating walls of fire, sometimes called curtains. A lava curtain can sometimes be more than a mile long and reach heights of over 150 feet. Lava lakes are formed when lava fills a depression. The edges of these lakes resemble ocean shorelines. But these are lakes in which you wouldn't want to swim. Temperatures exceed 2,000 degrees Fahrenheit. Lava spattering is common in these lakes, and sometimes the spattering moves eerily across the surface as if some creature were thrashing about below. Sometimes, the lake's surface resembles the plates of our planet, but in miniature, folding, bending, subducting. Lava domes will occasionally form on the lake and may last for hours. When the lake becomes too full, it overflows. Lava rushes down the volcano's slopes in rivers. In some places, the rivers run fast. In others, they slow to a crawl. When a flow begins to slow down, the surface will cool and harden, sometimes encasing flowing lava beneath it, creating a lava tube. Holes in lava tubes are called windows or skylights and provide glimpses of the rushing lava below. Lava tubes are good insulators, and the lava flowing in them will remain hot and fluid much longer than it does in surface flows. When flows exit tubes, they will often broaden, burning their way through forests, crossing roads, engulfing vehicles and homes. Lava is slow-moving, and people have time to escape with a few possessions and pets. Some try to save their homes. Water is sometimes used in an attempt to stop lava in its tracks. Using just 2 garden hoses, 2 men were able to divert a lava flow around this house. And it worked for a few days, but as is often the case, the home would eventually go up in flames. There are different types of lava. One is very fluid. It has the consistency of thick cream. It is called pahoehoe lava. Another lava type is thick and chunky, and usually slow-moving. It is called aa lava. In some places, the lava slows to a stop, hardening into black rock as it cools. In other places, the lava doesn't stop, reaching the ocean. Here, you sense a battle as fire meets water. Steam explosions are common as the lava explodes as it hardens. This unusual lava flow is called fire hose lava. At night, the explosions take on an eerie quality. Beneath the water, lava quickly crusts over and then cracks open again, like the egg of an alien creature. This kind of lava is known as pillow lava because of its pillowy shape and has seldom been photographed. Back on the surface, new shorelines form under clouds of hissing steam. What has been destruction now becomes construction as new land is formed, and the big island of Hawaii is now a little bit bigger. Hawaii's volcanoes are referred to as shield volcanoes, their shapes resembling warrior shields. Shield volcanoes have gentle slopes, seldom explode and are not considered particularly destructive. Other volcanoes have steeper sides and resemble cones. They are called cinder cone volcanoes. This is an example of a cinder cone volcano. Notice the steep slopes. The third type of volcano has features of both shield and cinder cone volcanoes. They are called composite volcanoes. The bases of composite volcanoes usually have gentle slopes, but the slopes at the top are usually steeper. This is an example of a composite volcano, Mount Shasta in California. Again, notice how the slopes are steeper near the top. Most of the world's destructive volcanoes, such as Mount St. Helens, are composite volcanoes. Composite volcanoes can be dangerous, and that's why scientists study them, in the hope of learning more about them and our ever-changing planet. In this program, we have seen that volcanoes are a type of mountain. Volcanoes are created in several ways. One way is when one plate subducts or dives beneath another, causing magma to rise to the Earth's surface and erupt. Another way is when magma rises through the Earth's crust above hotspots. We have seen how most volcanoes are located near subduction zones, and that most of the world's active volcanoes are located in an area known as the Ring of Fire. Finally, we've seen that there are three different types of volcanoes: shield volcanoes, cinder cone volcanoes, and composite volcanoes. While we are impressed by the explosive nature of volcanoes and their fiery displays, we should remember that volcanoes and volcanic activity help contribute to the continuing regeneration of our planet.